Hi everyone, welcome back, and we are going to talk about ANOVA analysis today. So that's analysis of variance testing, and it can be used when we're comparing at least two groups that are different from one another, and returns an F statistic. So let's look at a one-way ANOVA analysis. So this is analysis used commonly in biology and bioengineering and chemistry to look at our samples. Basically, are we looking at different conditions, statistically significant conditions? So you go through this kind of long analysis of calculating the means of means, calculating what's called sum of squares, error of sum of squares, total sum of squares, your DF error, DF total, MS treatment, MS error, and then finally this F ratio. So we can do the same thing with Mathematica in kind of one shot in this table. And we can see this F ratio is the same here. We get kind of the same error here, sum of squares values, etc., etc., etc. But the question is, how do we actually talk about this table? The higher your F ratio, your FR ratio or your F ratio is very similar to your T or your Z values. But it's a function of N and M, which correlate to basically your DF and your DFA respectively. So we can calculate that. So the basic sense is the larger the F value, the greater the difference between the groups. So kind of like our outliers, our Z's, et cetera, et cetera. Additionally, this P value, if it's less than our confidence interval, usually 95%, or less than, if the P value is less than alpha of 0.05, then there are significant differences between our groups. So we can actually calculate that and look at this, our ratio here. We can kind of provide this function here. Plug in, make sure our X is defined here so we don't get any errors. So this is what our FR ratio or F ratio looks like. And if you integrate it from 0 to infinity, we get 1. And you can see for our F value, basically all our values are going to fall in between here. So I could look at multiple kind of scenarios or case functions. I could do two-way ANOVAs. I could do three-way ANOVAs. So you can compare lots and lots and lots of different test conditions in order to kind of figure that out. So I just want to introduce that because it's something that we don't normally get to talk about in class. So, all right, next time we'll get into the statistics of our fits, and then we'll be done with lecture 3, and then we'll get into some fun image analysis next time. All right, thanks. See you all next time. Bye.